Okay everyone, we'll start with the session. Please send a message or in the chat window whether my voice is audible. Okay, thank you Pavitra. So we have been seeing the sessions from last 4 weeks, and today we'll be starting with the week 5 theory. So first I'll just go through the theory as I do every time, and next after that we'll move on to the assignments. So briefly I'll move through the theories which were shared in the week 5 lecture slides. So this is what we have been looking. So constraints optimization. So unconstrained optimization. So in the last week the functions we examined were unconstrained, meaning that they either had no boundaries or the boundaries were soft. Okay. So now this week we are looking at constrained optimization. So in this week we will be examining the functions with constraint. So the constraint is a hard limit placed on the value of a variable which prevents us from going forever in certain directions. So you can see the graph here. Earlier when there was no constraint present, it was like this. Now a hard line is placed, and within this constraints we have to move. Okay. So example is like traveling from Surat to Mumbai constraint. Okay. So here you can see that if there is no constraint, that is like if you want to travel from here to here without any constraint, this is the direction shown by the maps. Now if we are giving like any constraint, like we must visit this city, Nashik city, then if we place that add stop like that, then the maps will give another direction. Okay, so this is known as the constraint. So if we place this constraint, the direction and the map will take another path. Alright, so let's move on to the next slide. So the task or problem, just this picture: climb as high as possible on the mountain to have a better view of the moon. So the constraint is like the car must be on the road. Okay, so if it has to be on the road, it has to follow a certain path, otherwise it can go any way to reach the highest possible place. Okay, now equality constraint optimization. So this example you might have seen in your class. Like if you have like minimize this function 2x1 square plus 4x2 square subject to this constraint which is given by 3x1 plus 3x2 equal to 12. So this is known as the constraint unconstrained minimum. So this function has this particular contour and the minimum comes at this place. But if you are defining this particular constraint, then this constraint will match with this particular point. So in case if we give a constraint to a particular function, here it will be present. Okay, now I have an example. So for a rectangle whose perimeter is 20 meter, find the dimensions that will maximize the area. Okay, so let's consider breadth b equal b, length equal to L, area A and perimeter P. So similar kind of problem we had seen earlier also, but now the constraint is like earlier it was like maximize either the area or maximize either the perimeter with for given values. But here it's like this is the intention. Our intention is to maximize the area subject to the constraint which is given like perimeter is 20 meter. So constraint will give us, this is how you calculate the perimeter, 2 into L plus B. So that is given as 20. So in a constraint condition, the first order will be like, first order condition will be given as I think you might have learned like minus of okay, minus of del f is equal to lambda into del g, where f is the function and g is the constraint. Okay, so in this case, if you give, you can write it as like the del f will be coming like the area is the function here. So the first one will be with respect to length, and next one will be respect to, differentiation will be respect to breadth. So anyway, it will be coming like, for the first one, del f will be coming like breadth and b and l actually, and the other one del g will be coming like so it is like 2l plus 2b. So here it will be coming like 2 and 2. So our condition is like del f is equal to lambda into g. So in that particular case, it can be written as b equal to minus b equal to 2 into lambda. Okay, that means b equal to minus 2 lambda, and the another one is l equal to minus l equal to 2 lambda. That means l equal to minus 2 lambda, and the other equation, this is this one. So solving all the three given here, we can get this as l equal to b, and putting these values in the equation 3. So if you give l equal to b here, then you will get like the value of l or b will be like 5 meters. Okay, so this will be obtained. Then we can calculate the area as 5 into 5 equal to 25. Okay, then now find the points on the circle. This question also you might have seen, and anyway we'll look at this again. So find the points on the circle, x square plus y square equal to 80. So this is the circle. Okay, which find the points on the circle which are closest to and farthest from the point 1, 2. So 1, 2 is a point here. We have to find the farthest and the closest point. Okay, so from this figure, it's given like this, 4, 8 and minus 4, minus 8. We'll see how to obtain that. So the distance d from any point x5 to the point 1, 2. So distance from a point is usually given as like root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the distance between 2 points. So in that way, we are here writing as x minus, so we don't know the point, so x minus 1 whole square plus y minus 2 the whole square. So this is the distance. Okay, now we have this function f of xy equal to x minus 1 whole square plus y minus 2 whole square. Okay, we'll take the function like this one. Okay, so our thing is like we have to find the closest and farthest point. Okay, so one of the cases we will see. So maximize this one subject to the constraint, this one, x square plus y square equal to 80, that is the circle. Okay, so this point should lie on the circle, so this is the constraint. Okay, this is the constraint. Now del of f of xy equal to minus lambda del of g of xy. So dou f by dou x will get like these two. Okay, and dou g by dou x like this we will get, and finally we will equate these two actually, x minus 1 equal to, here it will come like in this way. So if you write here according to the constraint equation, x minus 1 equal to lambda into minus lambda into x it will come. So likewise y minus 2 equal to minus, okay, lambda into 2x and minus lambda into 2y it will come. So in this way, when you see, it can be taken like this. Okay, sorry, 2 I should remove from there. not like this. It is actually minus lambda x and minus lambda y. Okay, so this is the function, and so we'll get like x minus 1 equal to x minus 1 by x equal to minus lambda, y minus 2 by y equal to minus lambda, and this is the constraint. So when we solve all these equations, so solving 1 and 2 will give y equal to 2x, and when it is substituted in here, you will get this particular answer like x is equal to plus or minus 4. Now putting values, this will come like y equal to plus or minus 8 with this equation. So we obtain the points where 4, 8 is the nearest, and minus 4, 8, minus 8 is the farthest point from 1, 2. Okay. Now another question, f of x, y, z is given as this one, g of x, y, z is given like this. So it's explained here. So del of x, f of x, y, z. So now there are 3 variables here, x, y, z, as well as one lambda is there. So when you see the first order condition, so first order condition for f, it will come like, I'll just solve and give that. So del f will be coming like, first it will be coming like 1, next it will be coming like 0, and third 1. Okay, and del g will be coming like 2x, 2y and 2z. So in that way, if you write minus del f equal to lambda del g, or del f equal to, in the same way you can write del f equal to minus lambda del g, del g. Okay, so if you write like that, then these equations will be coming. So when we solve these 3 equations, we will get x equal to z, and y equal to 0 we will get from 2. So when you substitute all these in the constraint equation, we will get x equal to this much. So z is also this one. So these 2 points will be root 1 by 2, 1 by root 0, root 1 by 2. Likewise, point 2 will also be obtained. Okay. Then inequality constraint optimization. So here in this case, you have to minimize a function subject to an inequality. Earlier it was an equality. So in the equality case, you will be, if it was an equality case, then it was like del f equal to minus lambda del g. Now in this case, it's an inequality constraint optimization. So the same figure will come. This is the unconstrained minimum, this is the constrained minimum, but in this case this function will be like an inequality. Okay, that we will see. So just a function is given for x2 square subject to the constraint 3x1 plus 2x2 equal to 12, and 2x1 plus 5x2 equal to 10, and x1 less than or equal to 1. So this is the feasible region where your solution should come. So within that you have to do it. So for solving an equation like that, so this example you have seen there in the lecture slides itself. So I'll just go through that briefly. So your function is to minimize 2x1 plus 4x2, 2x1 square plus 4x2 whole square. So you can define the Lagrangian as 2x1 square plus 4x2 square plus mu1. This you have seen actually. You have 2 constraints. So for one, in this one, you have to find out what you have to keep inactive or active, because there are actually x1, x2, mu1, mu2 and mu3. There are 5 variables are there. So at least you should have 5 equations. So here there are 1, 2, 3 equations are there. So either you have to take these and give mu1 mu2 anything as 0, or if you are taking only one mu1 as 0 for example, then the other two constraints you have to equate it to 0. Okay, so just we will take the first one. So this is the Lagrangian which we have to write. So mu1 into, so one thing you have to make sure is that all these things should be like less than or equal to. Okay, so here you will be changing this second one as b equation will be changed as 10 minus 2x1 minus 5x2. Okay, so that will be coming like less than or equal to 0. Okay, so the first equation will be like 3x1 plus 2x2 minus 12 less than or equal to 0. The second one you will be changing in this form, and x1 minus 1 equal less than or equal to 0. Okay, this one will be coming like x1 minus 1 less than or equal to 0. A will be coming like 3x1 plus 2x2 minus 12 less than or equal to 0. Okay, so in this one you have putting mu1 into 3x1 plus 2x2 minus 12 and 10 minus 2x1 minus 5x2. Sorry, yeah, and in the third one mu3 into x1 minus 1. So the first order KKT conditions will be, this one is derived from this particular one. Okay, so it is like with respect to x1. Okay, dou L by dou x1 if you do, then it will be coming like 4x1, it will be like 4x1 plus 3 mu1 minus 2 mu2 plus mu3 equal to 0. That is the first thing. And the second thing will be like x2, if you have to give it like dou L by dou x2. So here it will be coming like 8x2 plus 2 mu1 minus 5 mu2 equal to 0. So you have one equation here and two here. So you need 3 more because your total thing is 5. Okay, 5 variables are there. So for that you will be writing mu1 into 3x1 plus 2x2 minus 12 equal to 0, mu2 into 10 minus 2x1 minus 5x2 equal to 0, and mu3 equal to x3 minus 1 equal to 0, mu1 mu I greater than or equal to 0. So we will be seeing a table on how to do this one. Okay, so in this one you need 3 more. So either you can give, if you give mu1 and mu2 equal to 0, then only this condition will be active, x3 minus 1 will be active, the other constraints will be inactive. Okay, and in case if you are giving only mu1 equal to 0, then the other two constraints will be active. So in that way there is a table. Okay, so in this table we have seen many different ways in which we can find the solution. So here for example in the sixth case, the second constraint is active and the other are inactive. That means like mu1 and mu3 are given as 0, and then you are solving the equation and you will find out like this. So one condition is satisfied, like mu I greater than 0, that is satisfied here, and you will get the x1 x2 values. But you can see in the previous slide that it is given x1 should be less than or equal to 1. So when you solve this particular equation, x1 is coming like 1.21. So this is not a possible optimal solution. That is, since x1 less than 1 is not satisfied. Another thing which you might have seen is like you might have given mu2 and mu3. In this case mu2 equal to 0 and mu3 equal to 0. So in that case, when you found out the mu1 value was coming like this, so this is like it should be greater than 0, as well as the x1 value is also going higher than 1. So this also is not a solution. In the fourth case, just we will see, here we have given just the first constraint as inactive, then the rest of the constraints are active, so mu1 equal to 0, then you are getting these two. Anyway, these two are greater than 0, so that is satisfied. And in the first case, x1 is less than or equal to 1, so all constraints and KKT conditions are satisfied here, so it is the possible optimal solution. All the rest are not the solution. So according to that, the plots were also given. Okay, so in this case you can see here that this is the possible optimal solution. In the rest of the case, both the constraints are not matching. Okay, constraint minimum and constraint minimum, they are not matching, but here it is matching. Okay, now we will move on to the assignment questions. So because after the 2 slides we were moving on to the introduction to data science, so for that part I will be moving on to the RStudio later. First we will solve the week 5 assignment questions of the previous run 2 courses. Okay, and after that we will be looking at a certain data set and how to start analyzing that particular data set. So first question is like, which of the following statements is or are true with respect to the multivariate optimization? So it is given like, first, the gradient of a function at a point is parallel to the contours is given. Second one, gradient points in direction. So you can just read these 4 points and tell me which one is not true. Okay, the important thing is that you have to find the thing which is not true. Okay, so by looking at this one, gradient points in the direction of greatest increase of the function, that is right, and negative gradient points in the direction of greatest decrease of the function, that is also right. Is this first one right? The gradient of a function at a point is parallel to the contours, is that right? Yes. So can you tell me the answer? Next one is given like Hessian is a non-symmetric matrix. This portion is there in the last week itself. So what are the incorrect options? Yes, 1 and 4. That is right. So the answer is 1 and 4. Okay. Then the solution to an unconstrained optimization problem is always the same as the solution to the constrained one. Is this true or false? Is it the same? Is the solution same for unconstrained and constrained problem? You have seen, no? For constrained you will be giving like del f equal to, yeah, it is false. You have answered right, so the answer is false. Okay, then gradient based algorithm methods compute what can be the thing, only one step length or both direction and step length at each iteration, or only direction, or none of the above. What will be the answer here? Yes, this is the answer. Okay, and for an unconstrained multivariate optimization, given this one, this necessary second order condition to be the minimizer of f of x will be, this is also direct question only, A, B, C, D. Which one will be the answer? A, B, C, D. Okay, you can tell me. This is from the last week only. The second order condition was asked. Necessary second order condition. Yeah. First order condition will be this one, and the second order will be like the Hessian matrix. This is the Hessian matrix, should be positive definite. Okay. Somebody is putting D. I'm not sure why. This is not that case. Okay, the B is the correct answer, right? Okay, B is the correct answer. Kaushik, I think you have understood. Yes. Okay. Use the following information to answer question 5, 6, 7 and 8. So this is the question. X1 square plus 4x2 square minus 2x1 plus 8x2. So here you can see that it is minimize function. Okay, it is given minimize f is equal to x1 square plus 4x2 square minus 2x1 plus 8x2. Okay, so first it is asked which among the following is a stationary point for x1, x2. You also can just find it out first. Okay, I will also solve this one. So here for that you have to find del f, and there you can see that it will be like dou f by dou x1, dou f by dou x2. So if you solve this one, okay, you'll be getting it like 2x1 minus 2 and 8x2 minus 8x2 plus 8. So if you give del f equal to 0, you will be getting the points 2x1 minus 2 equal to 0, x1 equal to 1 and 8x2 plus 8 equal to 0, x2 equal to minus 1. Okay, so x1 comma x2 equal to 1 minus 1 will be the answer, right? So next we'll move on. I hope this is clear. Next we'll move on to the second question, connected question. Find the eigenvalues corresponding to the Hessian matrix of F. So this is also straightforward. Find the eigenvalues. So first you have to find the Hessian matrix del square of F. So how will you find del square? It is like dou f by dou square f by dou x1 square, then dou square f by dou x1 x2, then dou square f by dou x2 x1 and dou square f by dou x2 square. So if you solve this particular thing, for those who don't remember from last week, okay, so how can you do it? Dou x1 by dou f by dou x1 is this one. If you differentiate again with respect to x1, then you will get 2. Then x1 with respect to x2, if you do, 0 will be coming. Since Hessian is a symmetric matrix, you can give like 0 here also. And 8x2 plus 8, if you give with respect to x2, if you differentiate with respect to x2, you will be getting like 8 again. So that is the thing, okay. And now you have to find the eigenvalues. So a minus lambda I, determinant of a minus lambda I equal to 0. Just you have to give determinant of 2 minus lambda 0, 0, 8 minus lambda. This is the equation. So 2 minus lambda into 8 minus lambda equal to 0. You will be getting this as lambda equal to 2 as well as 8, right? So these are the eigenvalues. If you see here, 2 comma 8 is the eigenvalue. Okay, I hope this is clear till now. Then find the minimum value of f. Okay, so you got the eigenvalues as 2, 8. So you the matrix is also positive definite also, the Hessian matrix, and you got the eigenvalues. So the value for x1 x2, I'll write it here. Value for x1 x2 you got like 1 and minus 1. All right, so the function is x1 square plus 4x2 minus 2x1 plus 8x2, x1 square plus 4x2 square minus 2x1 plus 8x2. This was the function. Just I'll check again. X1 square plus 4x2 square minus 2x1 plus 8x2. Okay, this was the function. So you want to find the minimum value. So minimum value, how can you find? Just substitute the values for x1 and x2. So 1 plus 4 minus 2 minus 8, it will be coming like minus 5. Okay, f of x1 comma x2 at x1 equal to 1, x2 equal to minus 1. So you will be getting like minus 5. And the next one, what is the minimum value of f of x1 x2 subject to the constraint x1 plus 2x2 equal to 7. So now the present week lecture will be coming. So the function I'll write again. The function here is f of x1 comma x2 equal to x1 square plus 4x2 square plus, okay, it was not plus, minus x minus 2x1 plus 8x2. Okay, this is the function, and the constraint is like x1 plus 2x2 equal to 7. Okay, so that you can write like x1 plus 2x2 minus 7 equal to 0. Okay, so first del f you have to find. So del f you had already found out, and you got like 2x1 minus 2, and this one 8x2 plus 8. Okay, and del g of x1 x2 is the other constraint. Okay, g of x1 x2. So that when you find out, you will be getting like first is 1, and the next one with respect to x2, if you differentiate, you will be getting like so you'll be getting like this one. Okay, so del f equal to minus lambda into del g. Okay, like this we have to write for constraint. Okay, with equality constraints, this is the condition. So if you give this like this one, you will get 2x1 minus 2 equal to 1, and next one 8x2 plus 8, 1 minus 1 lambda. Okay, and the next one will be coming like minus 2 lambda. Okay, so then solve for this one. X1 will be coming like 2 minus lambda by 2, and x2 will be coming like 8 minus 2 lambda by 8. Okay, that will be coming. So then you can solve these two, you can put inside this particular equation and get the solution. So here if I give this equation as 2, then from 2 will be coming like 2 minus lambda by 2 plus 2 into 8 minus 2 lambda by 8 minus 7 equal to 0. So you can make the denominator same. So in that way I'll just put like 4 minus 2 lambda by 4 plus 8 minus 2 lambda by 4 equal to 7. Okay, so if you calculate this one, you will be getting like 12 minus 4 lambda equal to 28, or you'll be getting like minus 4 lambda equal to how much you'll be getting? 16, and lambda equal to minus 4, and from that you will be getting x1 like, is this fine for everyone till now? You'll be getting x1 like 3 and x2 as 2. Is this fine till now? Have anyone solved till now? Answer 7. 7 meaning? Just I'll go to the previous thing. Till now we have solved till here. Salman, what do you mean by answer 7 here? Okay, we'll solve the rest also. So we have reached till here, 2 minus lambda. Oh, there is one problem here, right? No, that's fine. I think here there is one problem, minus 8. So it will be coming like minus 8 minus 2 lambda, minus 8 minus 2 lambda here. So it will be coming like minus 4 lambda. Okay, yeah. So in that case, this will be coming like minus 4 lambda equal to 24 lambda equal to, sorry, just wait a moment. Okay, yeah, that is right, Swami. Okay, that is right, 27 is the answer. So I'll just solve from here. Also I have made a mistake here. So x2 equal to minus 8 minus 2 lambda by 8. So 2 minus lambda by 2, and 2 into minus 8 minus 2 lambda by 8 minus 7 equal to 0. That is the equation that you have to give. Then 4 minus 2 lambda by 4 and minus 8 minus 2 lambda equal to 7. So here if you solve this one, you will be getting minus 4 lambda by 4 equal to, so it will be coming like 27 here. Then minus 4 lambda equal to 32 lambda equal to minus 6 will be coming. Is that right? I think I have made some mistake. Can anyone tell me what I have made here? 5 1 is the answer you are getting for x1 comma x2, right? Just let me see if I have copied everything correctly. Hmm, 2x2 plus 3. Okay, let me see. Wait. What was the question? For x1 square plus 4x2 square minus 2x1 plus 8x2. That is right. And so it will be coming like 2x1 minus 2. Okay, 8x2 plus 8. And constraint is like 1 and 2. Okay. So this will be coming like 2x1 minus 2 equal to minus lambda into 1, and this one 8x2 plus 8 equal to minus lambda into 2. Okay, so in this way it's like 2x1 equal to 2 minus lambda, and here 8x2 equal to minus 8 minus 2 lambda. So what will be happening? So here x1 equal to 2 minus lambda by 2, and here x2 equal to minus 8 minus 2 lambda by 8. So then what you have to do is just put that in the equation. 2 minus lambda by 2, multiply 1 with 2. Yeah, that also you can do. Yeah, that you can do. Okay, so wait a minute. Okay, so this will be coming like x1 plus 2x2. So 2x2 will be like minus 2 minus lambda by 2 equal to 0. I didn't understand what you meant by multiplying 1 with 2. 4x1 minus 4. Okay, still I'll try this way. Anyway, I didn't understand what you were saying. Sorry. Sorry, 7. This is 7.
When we multiply 1 by 2, then both sides will be minus 2 minus 2 lambda. Then we can say 4x1 minus 4 is equal to 8x2 plus 8, like that.
Okay, yeah. But in this way also you can solve.
Yeah. Then it becomes x1 is equal to x2 plus 3. Then that we have to substitute in this constraint condition. x1 plus 2 x2 is equal to 7. Then we'll get x2 is equal to 1 and x1 is equal to 5.
Okay, so I think you have got it like that. Okay, but still in this way also it is possible I'm making some mistake in between actually. So okay, I'll figure that out later. So anyway you can solve it actually. So you'll be getting like x1 equal to 5 and 1 finally. So next after that you just substitute in the f of x1 x2 and there you'll be getting the answer. Okay, that will be the final answer.
Or you can solve it as 3 simultaneous is equal to 0 and the constraint x1 x2 7. You can view it as 3 equations with 3 unknowns x1 x2 and lambda. So when we solve it, you can easily solve it, but by this method getting the lambda value to be negative.
Yes, okay. Anyway, the final answer will be 27. Okay, this I have solved it earlier also.
Okay.
Yeah. But now I am making some mistake here and cannot figure it now actually. Sorry for that. Anyway, one has given this particular way of solving also. It can be solved in this way also. Find x1 and x2 from this, and if you substitute in this equation, you'll be getting that. Okay. That is also possible anyway. I have solved it like that also. But the final answer will be coming like 27. I hope that's clear. So if anyone has any doubt again at the end of the session, I will be solving again. Okay. Okay. So the next one, find the maximum value of f of xy equal to 49 minus x square minus y square subject to the constraint x plus 3y equal to 10. So this is similar, but you have to find the maximum value. I think you can solve this one and tell me the answer. Similar question only. Okay, so I'll just start solving. You can solve with me also. So first one is given like f of xy equal to 49 minus x square minus y square. Just find the del f first. Okay, so you can tell me what comes as the answer. So we have to get dou f by dou x and dou f by dou y. So it will be coming, I think here one is unmuted, right? Okay, anyway, so the first thing is like this one. Okay, so you can solve and tell me the answer. I'll also be just solving that, and constraint x plus 3y minus 10 equal to 0. So this will be coming like 1 and 3. So del f equal to minus lambda into del g. Okay, so you will be getting different values for that. Minus 2x equal to minus lambda and minus 2y equal to minus 3 lambda. So in this case you will be getting lambda x equal to lambda by 2 and y equal to 3 lambda by 2. And now if you solve in the first equation, lambda by 2 plus 3 into 3 lambda by 2 minus 10 equal to 0. So it will be coming like 10 lambda by 2 minus 10 equal to 0. You will be getting lambda as 2. Till now, is it fine? Okay, so then you have to find the x and y value. So x value will be coming like 1 and y value will be coming like 3, and later in f of xy, if you are putting it like 1 comma 3 for x and y, if you are putting, then it will be coming like 49 minus 1 minus 9. Okay, so you'll be getting like 39. Is this fine with everyone? Yeah. So this is the answer. Okay, so anyway, you have got that also, so that's fine. Now consider an optimization problem. Yes, everyone is getting, I think. Optimization problem: minimize x1, x2, minimize x square minus xy plus y square, subject to the constraint this one. Okay, so first question is like find the Lagrangian for the above optimization problem. So direct question only, you can tell the answer. So if you are writing the Lagrangian for x comma y comma mu1 comma mu2 comma mu3, then you will be getting, first you have to write the equation plus y square, that will be the first one. Then the next one will be plus mu1 into, first constraint is anyway less than 1, so 2x plus y minus 1, plus next one mu2. Okay, Hariom is giving first option. Yes, okay, that is true. So second one you have to change it like 2 minus x minus 2y to make it in the less than or equal to condition, and the third one mu3 into minus x minus 1. So in that case you will be getting the first option. Okay, I hope that's clear with everyone. I'll move on to the next one. So next one is some practice questions. So till now is what have been given in your previous assignment in the course. Now we'll move on to the assignments which were given prior to the prior course actually. Okay, so 2 courses before. So here it is given like maximize this function equal to xy. Okay, subject to the conditions x plus y square less than or equal to 2, xy greater than 0. The Lagrangian function is also given, xy minus mu1. They have given it like that. Okay, 2 minus x minus y square minus mu2 into x minus mu3 into y. So which of the following is not an apt representation of the constraint? That you can give. Which one is not an apt representation of this one? You have wrote the Lagrangian here. Which one is not an apt representation of the constraint? You can tell the answer.
First one, no need to change the sign because it is already a minimized less than or equal to constraint.
It's asked which is not an apt representation. Okay, I'll move on to the solution. So the solution is this one. Okay, first one is right, yeah, middle option many are giving. So the second one is like it's not mentioned as part of problem. It's given x is greater than or equal to 0, right? It's not like minus x is greater than or equal to 0. Okay, so this is not an apt representation. The given constraint has not been mentioned as a part of the problem. Okay, I hope that's clear. Now the next one, consider the objective function max f of x equal to xy subject to this one. It's the same question only, connected one. So the Lagrangian is also given like that. The values of mu1, mu2, mu3 while calculating the KKT condition with all constraints being inactive are. This is also straightforward. You can tell the answer.
All mu's are zeros.
Yes. Yeah. So when all constraints are inactive, mu1 equal to mu2 equal to mu3 equal to 0. Right. So then the function f 5x square plus 3y square plus 8xy plus 12x plus 6y as a function to be optimized, and answer this question. f of xy, the saddle point of the function f of xy exists in which of the coordinates of the following coordinates. So this you have to solve. You can solve and tell me the answer. What is the x and y values you are getting? It's direct question only. Just you have to find out dou f by dou x and dou f by dou y and equate it to 0. I'll just start solving that one for the time being. So 10x plus 8y plus 12, and here it will be coming like 6y. Yeah, anyone getting the answer? Is anyone speaking?
Y is equal to minus 9.
Yeah.
Then
X equal to
7 into minus 9. X is equal to 6.
Okay, that's right. So this is the answer. Everyone is getting these answers right? Okay, then fine. Yeah, then answer is 6 and minus 9. Okay, so just I have given it like solving these two equations, 10x plus 8y minus equal to minus 12 and 8x plus 6y equal to minus 6. You'll be getting x equal to 6 and y equal to minus 9. Okay, now another question. Circle with center at origin is defined as x square plus y square is equal to 250. Find the points on the circle at the minimum distance from the point 10, 1. So similar question you have done also. This you can take this one as f of xy, and sorry, this one is the constraint. Okay, and find the points on the circle at the minimum distance. So you have to minimize the function. So you have to write it like minimize f of xy equal to, you have to apply the distance formula. So it is like, I mean earlier also you have seen it like x root of x1 square minus x2 square plus y1 y2 square y2 minus y1 the whole square, x2 minus x1 the whole square plus y2 minus y1 the whole square. So here it will be like, sorry, y minus 1 whole square, so root of this one. So you can write the function as anyway x minus 10 the whole square plus y minus 1 the whole square. This is the one you have to minimize, and you have your constraint g of xy as x square plus y square minus 250 equal to 0. This is the constraint. You can solve this one and find the answer. In this case there is another way of solving this also. Actually you have solved it like del f equal to minus lambda into del g, like that is there. So you can solve it in another way, I mean the same thing only. Dou of xy by dou x, you can write this equation into dou g of xy by dou y minus dou f of xy by dou y into dou g of xy by dou x equal to 0. In this way also you can solve it directly. You can solve the usual method, or in this way also you can solve. I think the one who is unmute right now. Okay. Yeah. So tell me the answer. In this way, I mean, it will be coming like here it will be coming like 2x minus 10 into, in this way if you are solving, dg of xy equal to into 2x minus, with respect to y it will be coming like 2 into y minus 1 into, this will be coming like 2y equal to 0, and if you solve this thing you will be getting like x equal to 10y. Till this step everyone has reached, I think. And later if you substitute in this one like in the equation, I will name it as this one, okay, this one. So if you substitute in that, you will be getting like 100y square plus y square equal to 250. You will be getting the y value as what? What is the answer you are getting? I hope everyone is solving. So you'll get the answer somewhere around y equal to 1.573 and x equal to 10y. So it will be like 17.733. Say 15.733. And it will be like plus or minus values. Okay, so I hope everyone have solved it. X equal to plus or minus 15.733 and y equal to 1.573. okay, so you have to see which is closer to 10.1. okay, you have 2 points here. One can be like 15, so I'll just come here. One can be like 15.733 and this is point, okay, 1.573, that is 1 point, and the next one is minus 15.733 and minus 1.573. okay, so in these 2 points, which one will be closer? This one will be closer to 10.1, 10,1. So this will be the answer and you will be getting the first option. Okay, I hope everyone got this one. Any doubts you can just mention. So I'm waiting if any doubts are there. Just put in the chat window if you have any doubts. Otherwise we will move on to the next one. Okay. If you check this one, whether you want to maximize this square root or you want to maximize this function or minimize this function, it will be the same only. Okay, So this one function will be like, you, for example, if you put it like h of xy equal to root of this one, square of h of xy will be this one. Okay, so the maximization of minimization will be coming similar. So if you remove the square root also, the function will be coming same only you are getting like the square of the distance only. So if you find the minimum of the distance, then minimum of square of the distance will also be like having the same trend, right? If you are finding, if your minimum distance is 10, then the minimum square of the distance is like 100. It will be similar. So if you remove the square root by squaring the distance between the 2 points, then also you can minimize it. How did you get 10 minus x minus 10y? Yeah, I told you, no, you can solve in this way. How did you get? Okay, wait, just okay, this will be coming like this from this equation. Okay, 2 into x minus 10 into, okay, sorry, this is, I have just made a mistake here. It will be g of xy. Wait, with respect to y is 2y. Sorry, there is a type mistake there. Instead of x it is y. Okay, and here it's different. Okay, so 2 into x minus 10 into dg of xy by dou y will be 2y here. Okay, it will be 2y, and here f of xy by dou y will be 2 into y minus 1 into g of xy, dou g of xy by dou x will be 2x actually. Okay, I think you will be getting it now. It will be like 4xy minus 40y minus 2xy plus 4xy plus 2x equal to 0. Sorry, still there is a problem. This one will be like minus 2 into y minus, okay, so this is 4x. Okay, so now you are getting it like that, no? These two will be cancelled and 4x equal to 40y, so x equal to 10y. I hope that's clear. Sumati, is it clear? Okay, then we'll move on to the next one. So this is the thing. Okay, this is the function minimization, x minus 10 the whole square plus y minus 1 the whole square, and this is the constraint. So if you solve this one, it will be coming like this. Okay, so you can just refer to this later. Okay, so the next one is function is defined as f of xy equal to 10x plus 5y plus 29. Find the maximum such that the constraint f of 5x plus 5y square equal to 44 is satisfied using a Lagrange multiplier. So this Lagrange multiplier I think you have seen. Okay, so how will you start this one? First you have to write the Lagrange. L of x comma y comma your new variable will be lambda. So it will be like 10x plus 5y plus 29, okay, and then minus lambda we can put here, or if more variables are here, you will usually put mu1, mu2, mu3. So here only one constraint, so 5x, and this one is like 5x plus 5y square minus 44. Okay, this is the Lagrangian. So first you have to find out the x and y points, so you have to find the differentiation. I'll just put like L dash. Okay, so the different derivative of the Lagrangian. So this will be like, you have to find anyway the similar things only, dou x y lambda by dou x, then dou Lagrangian by dou y, this one by dou lambda. Okay, so this will be the whole thing. So here if you solve for this one, you will be getting like first one 10 minus 5 lambda, right, then 5 it is y square. Okay, so minus 10 lambda y, and the third one with respect to lambda is minus 5x minus 5y square plus 44. I think till this is fine. Now you have to substitute, equate this to 0. So you will be getting lambda equal to 2. Is it fine? I think it's fine. Okay. Then if you substitute in that, you will be getting the value of y as 1/4, and then if you substitute both of those values, or just this value here, y value here, if you put, you will be getting x as so it will be like minus 5x equal to minus 44 plus 5y square, and x will be 44 minus 5y square by 5. Answer will be coming like, what will be the answer? So y value you have to put like 1/4. Solve for that and get the answer. So right now you have got y value as 0.25. So anyway, this answer will be coming. You can solve this and find out what the answer you are getting. It will be coming around 8.738. Okay. So I think that's clear. So this is how you will be getting that. This is the Lagrangian, and differentiating it and equating it to 0, you will be getting lambda equal to 2, y equal to 0.25, that means 1/4, and x equal to 8.7375. Okay. Then a manufacturer incurs a monthly fixed cost of 7350 and a variable cost C of m given like that. Okay, this is the variable cost. So revenue generated by selling these units is, this one is the revenue. So how many units is produced every month? How many units produced every month will generate the maximum profit? Okay, so you can start solving this. I will be solving this parallelly. So first you have to see what is the cost for the manufacturer yearly. Okay, because you are finding the revenue. So revenue means like revenue minus the total cost will give you the profit actually. Okay, so here revenue is given, so here revenue is given like R of M. It's with respect to M actually here, one variable. So this is the revenue, and cost I will be representing total cost of M. Okay, this is the total cost. So total cost consists of a fixed cost of this much and a variable cost. Okay, so you have to give like 7350 plus, this is 5, okay, 50 plus 0.001 m cube minus 2m square plus 324 m, and they are asking for the profit. So with respect to M will be like R of M revenue minus the total cost of M. Okay, I think this till now it's fine. So we are asked to maximize the profit and find the M value. Okay, so we'll have to first find out what is P of M, the function. So here if you see that it is like minus, so the values will be coming around minus 0.001 m cube, and wait a moment, okay, sorry for disturbance. So minus 0.001 m cube minus 4 m.
I think, sorry, profit is total cost minus selling cost. It's a TC of M minus R of M.
It's like if your
profit, if you say,
this is the
you have to maximize profit.
Yeah,
profit is the total cost, production cost minus selling cost.
Yeah, that is the equation, but just think of it like this way. If you are making a particular product, for example, here it is like 7350 is the cost of production, and if you are selling it for $8,000, okay, so then revenue generated minus total cost. Yes, that is true, Hariom Tyagi. So just think of it this example. If your production cost is 7350 and the selling cost is, if you sell it for $8,000, then you will be getting like a profit. Otherwise it will be a loss. If you are selling it for a lesser price, it will be a loss. Is that fine? Who had asked that?
Means it should be a minimization of loss. So since it is given as maximization, it has to be a profit, logically speaking. If it is a loss, it is minimization of loss.
Are you sure it's like that?
Yeah, because m happens to be an integer. M cube. It has to be a positive integer. M has to be a positive integer. So how can, if the terms m square and m becomes negative, I think you can revisit.
Just okay, you can solve in this way. I will just put forward this thing. Okay, you want to maximize your profit. What will be profit actually, and what will be loss?
Production cost, that is variable cost.
No, don't look at the formula like that. When do you say you have got a profit in a particular
my production cost, my selling cost is more than production cost.
Selling price you can sell. Okay, if your selling price is more than your production cost, you can tell that. So if it's more, that's why I have given like the revenue. Okay. Revenue is your selling price minus the production cost. That's why I have given it like that.
Correct.
Yeah. So if you want to maximize this one, so it's a profit, it's not a loss. So it's, if it was a loss and you have to minimize that loss, then the equation would have come the different way. But now it's a profit, so the in profit means the revenue will be higher, so that you have given like R minus DC. Okay, so I'll just write the equation here. Minus, so this will be coming like this is minus 4m square, then this one 1065 minus 324m will be coming like I think it's 741m, and then minus 7350. Okay, just see if is there any mistake in the thing I have written. Okay, and dou P by dou M will be straightforward only, so it will be like 003 m square minus 8m plus 741. Okay, just solve for this one and tell me the answer. This one you have to equate it to 0, and m values you will be getting, just put that in a calculator, or you can solve it also. I mean, putting in the calculator will be easy. So anyone got the answer? Okay, Himanshu 90, yeah, that is right. So any other answer you have got, you might have got a negative answer also, I think. Okay, 1m value is 90, that is true. I mean, you'll be getting like 89 point something, actually 89.61 something, and so that can be given as 90, and you'll be getting one minus value also. I think it's somewhere around 2756 something. Okay, so anyway, the answer will be coming like m is equal to 90. Okay, so this is the equation. Based on the derivative necessary condition for the function, we will be getting m equal to this value and this value. Okay, so I'll just give a moment for everyone to solve this one and see if you are getting the same answer. Okay, I hope this is clear for everyone. I'll move on to the next one. Okay, if anyone known is having any doubt. Okay. So an optimization problem solved for n variables with one equality constraint will have tell me the answer.
N plus 1 equations with n plus 1 variables as lambda is one more variable.
Okay, that is true. So this problem will contain n plus 1 variables, n decision one variable and one multiplier variable lambda. So corresponding to the constraint which can be found using n plus 1 equations. Okay, so that is B is the answer. So now there is some extra questions. This also you can directly solve and tell me the answer. For a function f of xy equal to 2x square minus xy plus y square minus 3x minus y, stationary point is asked. You can solve and tell me the answer. Actually, you will be getting, I think this you might have solved earlier also. So dou f, just dou f by dou x, dou f by dou x will be coming like 4x minus y minus 3, and dou f by dou y will be coming like minus x plus 2y minus 1. Okay, then just substitute, solve these equations. Yeah, answer is 1 1. That is true. Then Hessian matrix for this one. Just wait a moment. You can find the answer and put in the chat window. Okay, Swami Vedayananda has put the answer as C. Okay, everyone got the answer, same answer. 4 minus 1 minus 1 and 2. That is the right answer, yes. Okay, fine, this is the right answer. Okay. Yeah, the eigenvalues of the Hessian matrix, that is the same question as earlier. So now you have to find the eigenvalues. Direct substitution, like 4 minus lambda minus 1 minus 1, 2 minus lambda, the determinant you have to solve and tell the answer. So it will be coming like 4 minus lambda into 2 minus lambda minus 1 equal to 0. If you solve for this one, you will be getting the answers, the eigenvalues, as either you can solve like this or directly give in RStudio and find eigen of the matrix. Okay, so anyway you will be getting the eigenvalues as 4.414 and 1.585, which is the answer given here. Okay, this is the solution from RStudio. I think that's why there is so many values after the decimal point. Are you getting? Is everyone getting that? So if there is any doubt, just put in the chat window. Okay, I hope that's fine. Okay, the Hessian matrix of this one. So you have found the matrix. Okay, just tell me if it's a positive definite, negative definite. Okay, so this was the Hessian matrix, right? Okay, yeah, you can tell that answer. Is it positive definite? What was the Hessian matrix? Okay, the eigenvalues you got like this. So anyway, you can tell. So one person, most of you are giving positive definite. What is the condition for positive definite? Just a revision.
All eigenvalues have to be positive. That is one way. Otherwise, determinant of every submatrix should also be positive.
Okay.
If you take 1 by 1 or 2 by 2, 3 by 3 like that.
Okay.
Take
Okay.
all
Yeah,
eigenvalues
that is
positive. So
yeah.
one answer.
Yeah, that is true. So this will be the answer. Okay. Then next one. Function f of xy equal to 2x square minus 2y square. What does it have? Stationary point. So this is like del f. If you find, it will be coming like 4x and minus 4y, right? If you put it to 0, then it will be coming like x equal to 0, y equal to 0. So you'll be getting like stationary point at 0, 0. Think this is also fine. Okay, so that's all for today, and we'll move on to the RStudio. Okay, because from the third lecture this week you have looked at introduction to data science, and furthermore, so next week you'll be seeing at different ways which you can solve a classification or a function approximation problem. So I think you have learned what is a classification and what is a function approximation problem. So just for that particular thing, I'll be just seeing a data set and just showing you different operations that you can do with a data set, so that next class when you are doing either the linear regression or everything you are doing, you can directly first do the analysis of the data set and do the learning. Okay, so this first thing, just ignore that, was finding the eigenvalues of the question that we are looking at. So this one you can see here, right? This was the answer for that question. Okay, so first what I'll do is that I'll give this particular data set to a value cars. Okay, so to a variable. So here you can see that this is a particular data set which is present in RStudio itself. So I'll just run this particular problem. So now you'll be getting like, this is the data set. Okay, these are the list of cars in that particular data set, and this one is like miles per gallon, like kilometer per hour, what you will say, and then number of cylinders, horsepower, everything. Okay, many different types of things are given in this particular thing. Okay, so first we will see the structure. Okay, structure of the data frame. So here you can see that, so first we viewed the data set, and this data set is now stored to this particular data frame. And when you see the structure str, you can see that everything is a number here. Okay, and just for your info, if you just put like data of like this, now you can see what all different data sets are available in RStudio in dataset, in the package datasets in RStudio. So here these are the different data sets available. Okay, these many different data sets are available, and in that we are just now looking at empty cars data set, which is a motor trend car road test. Okay, now so next we will look at sorting the data frame with respect to a particular column. Okay, so MPG is one particular column in the cars data frame. So first, if you want to give it in ascending order with the miles per gallon, so you can get it like order of cars, this one. So the normal syntax will give you the ascending order. So here you can see that if you put X ascending, okay, if you put cars X ascending, you can see here this is the whole data sets. We have sorted it according to that. So here you can see X ascending you have given here. So according to that you will be getting like this one. So this is one is having the minimum NPG, and from there you will be going till 33.1, which is the maximum available. So if you want to get it as a descending order, like for example starting with 33.9, then you have to give minus of this one. Okay, that's how you will find descending order. And when you print this particular one, now you can see the descending case. So first then it will be starting from this particular value, okay, the highest value with reference to MPG, because here we are given cars of MPG. So if you give it like that, this will be the descending. Now there are other ways to give it like that. If you give it like order like this, you don't have to first store it and then display it. Just you can store directly as cars of order of cars $MPG, which will access that particular column. So if you run this one, the same value will be coming. Now if for example if you want to change it in ascending order with respect to 2 of the columns, in that case you can just give it like that in a tuple, okay, now in like in rounded brackets there, and if you run it like that, now you can see it will be arranged according to the MPG as well as the cylinder. So here it can look like for example so such a case is not coming. First it is considering the miles per gallon, and then so right now you can look at this for 21.4. first the 4 cylinder is coming and next is 6 cylinder is coming. Okay, so first the first priority will be given to the MPG and then cars $cylinder. Okay, now these are the different variations by which you can do it. If you do in this way, that is the reverse order, you will be getting it like starting with the cylinder will be having more preference, and after that the sorting of the MPG will happen. Okay, now we will see how to read some data. So I have a particular data known as bank data available in this particular location. Okay, this is the location which you can see. So if I show it here, this is the location. Okay, so that is given like this. Okay, this is the location. So if you want to read a CSV file, so I'll just show the location. This is given like this. Okay, just I have copied that and I have kept it there. Okay, so if you want to read from this particular location, you have to give read.csv. So this is a CSV file, that's why I am giving read.csv. Otherwise it will be going for different other things. Okay, so read, there are different things actually, read.table, read.csv. I think you can see in the figure read.csv too. Many different things are there. Okay, so this is read.csv, and I'll be giving the path to that particular file. But here in this case, what you have to see is that you have to give the slashes as a forward slash. Usually in your system, when you find the path, it will be a backward slash, but when you are putting it as a path in the read CSV, it will be a forward slash. Okay, or you have to give double backward slashes. 2 backward slashes should be given. Okay, so this is the same in Python also, same thing is followed here. So now if you give that particular data will be read and stored as bank data. So that is the data frame. So this is the bank data. So we have read this and stored in the data frame bank_data. Okay, so this is the data set. Okay, so it is we will see how many entries. So this much entries are showing there. We will see how to find that out. Okay, so just if you want to find the number of rows, you can give n rows, and if you want to find the number of columns, you can give n columns. Okay, now if you want to find out the column names, you can just tell call names, then it will give you the names of the columns. So just you can look it like this also, bank data, these are the columns. Okay, so it will list the columns, call names will list the columns there. Now row names is just the index, you don't have to see, but still if you want to find out, these are the row names, this is the index for the rows. Okay, now if you give summary of bank data, then a list of things will come. So summary of bank data will give you the minimum value, then quartiles. I think you have learned during the visualization in week 1 or 2. So first quartile will be this one, median, mean, third quartile and maximum value. So this will be shown in that. Then so this is the first column. Okay, just showing that this is the first column. Okay, customer ID, so that's why it's coming, it will be coming like a number. Now then the next one, next column is the name. Okay, so for that name, the length will be shown and the class and type. It's so like it will be like a categorical value, the name will be like that, so that's why it's written like this. And for things where there are numerical values, minimum, quartiles, all quartiles and the maximum values will be shown. Okay, so that is the summary of bank data. Now if you want to see, okay, just see like this one. So factor is like you will be seeing the categories present. So if you give like that, bank data dot gender, if you give like that, it will be factoring this one. Okay, and if you see summary again, then just look at the gender column. So gender column, it will be converting it to the different categories which is present. Okay, so for name we can't give it like that because so many names will be coming, right? Name, surname and all. But for in the case of gender, there will be in this particular data set, it is given like male and female. So whatever categories are present, that will be given when you do this particular function like factor. Now just these all things you will be needing later when you are doing data analysis, before the machine learning part, before you are training a particular model which you will be learning next week. Before that you have to see certain analysis in the data. Okay, so first you will have learned like for problem definition, then after that many things you have learned, right? So in that particular thing where you will be seeing at the solution, I mean like solution conceptualization and problem characterization and all these things, certain kind of data pre-processing needs to be done. So in that case these different things will be useful. So first, if you want to view the bank data framed by the gender and the age, okay, then you can do it like that. So this is the customer ID, name, surname, gender, everything. And if you want to, so now it is like gender is coming first. Okay, so all the categories of females are listed there initially, and then only the next category is coming. And here also we have given the ages, so age will be starting from the smaller value. Okay, ascending order it will be going. Now show the bank data for male customers only. If you want to do like that, then you have to give view of bank data, and bank data inside the brackets you have to give gender as equal to male, then only the data which is having males only will be coming. Okay. Similarly, if you want to view it for a particular region, then also this region is there, England. Okay, other regions are also, but still if you want to see for one particular thing, this is the one. Okay. Now if you want to give some particular constraints here, like for example bank data of age of the people in that particular data set should be greater than 40 and the gender should be male. So these are different constraints that you're giving. So in that, if you want to see, now it will be giving you like greater than 40 as well as the gender is male. So these are the different ways you can do. So this is also a different case. Okay. Now if you want to see the average age, so bank data age is this column. So in that particular column, just give mean of that particular column, you will be getting the mean value. Okay. Now if you want to add new columns, just you can give the data frame name dollar, this one. If this particular column is, you can see that in this particular column, that column named as interest is not present there right now. So if you give bank data dollar interest, then it will form a new column, and that column content will be like 0.1 into the column named as balance. You can see that right now there is the column named balance. So 0.1 into the column balance will be giving you this particular thing. Okay. So I think that's fine. Now the if else statement, you have seen this if statement, for loops, etc. earlier also. We'll have a revision if time is there, but this is the if else statement. If else you can give right like this together. So bank data dollar interest 2, we will be forming a new column, and that is possible when bank data balance is greater than 50,000. Then you will be putting in the new column 0.1 into bank data balance. Otherwise, if it's not greater than 50,000, it will be 0.08 into bank data balance. So these things will be giving you the new columns like interest 2. So interest 1 you had given like 0.1 into balance. Now you have given an if else condition giving like if the balance is greater than 50,000, you have to give 0.1 into this one, and if it is else condition is coming like if it's less than 50,000, then it will be like 0.08. So if you gave that condition, this is the value you will be getting. Now just you can look at this one. So bank data of 3.5, I'm just giving like 3. Okay. So just I'm forcing that particular value there. Now you can just look at the thing 3,5. We are looking at 3,5. So here if you find there are no other missing values present that much here right now. Okay. So if you want to see like this, if you are forcing it and putting it again, now if you want to view, if you are viewing the bank data, you can see that you have forced it here like this. This is the third row and the fifth column. You have forced the value 3 into that particular cell. Okay. Now if you see the mean, you are getting the mean as this one. Earlier also you got the mean when age as that one only. Okay. 38 is the mean. So just see what happens if I change the row as a missing value, when a missing value is coming there but in that particular column. So I'm just forcing a missing value there. Now when you look at that, see the first row is coming like NA, it's coming. Okay. So if you are giving it like that, and now you are looking at mean. Okay. Now I'm running it again. It like everything will be coming like this one. Okay. Now what you have to do, if you want to ignore that particular missing value, then you have to give na.rm equal to true. Now still that missing value is present in the bank data, it is there, but if you give this particular statement na.rm equal to true, it will be coming like earlier itself. Okay. Similarly, this can be given in another way. You can give bank data all rows and the column age na.rm. This is another way to give that. You will be getting the same mean value. Okay. Now, if you want to find out if a particular value is NA or not, you can use the is NA. So the same can be applied for different columns also to find out if there is a missing value. So it will be giving, now NA x is given like NA, so is dot NA of x will give you true. That means that it is a missing value. Then if you give is not NA, it's not a missing value. Okay. Now you can do it with updating the age column, and missing values can be replaced with average. So right now in this particular thing, the age of the first column as NA. So you have seen certain imputation methods also. There are many different methods, but one thing you can do for numerical columns is like do the mean or average or the median. Okay. So that will depend on the data. So if your data is having a normal distribution, okay, then you can move forward with finding the mean and fill the missing value. Okay. So this particular thing is one of the basic methods by which you will do data imputation. There are many other methods available. So if your distribution is fine, then you can do the mean and fill in the missing value. But if you have a skewed distribution, like for example, if it is right skewed or left skewed, so the mean is not, the average is not coming in the middle of the bell-shaped curve. If it's like different from that, then what you have to do is you have to find the median in that particular case. So here what we'll do first with the mean. Okay. So first we will see if there is a missing value. So this is the first statement, is NA banked underscore data dot dollar age. That means that it will check whether there is a missing value in this particular column. So if I run that, you can see false, false, false like that, but at the first instant you can see that there is a true because there is one missing value there. Now it will check that first, and if it is there, if it is coming as true, then you have to fill it with mean, and mean also when you find it you have to give it like na.rm equal to true, otherwise its value will be returning as na itself, and otherwise if there is no na value, then replace it with the same value itself, whatever was present earlier. So if I run this particular program, now bank data dot age will be changed. Okay. So now if you see, you can see wherever there was this particular value earlier, NA earlier, now it's replaced with the mean value which was 38.68. Okay. I think that's fine with everyone. Now these are simple, just other things. Okay. Just if you want to see data frames like this, just I will show you what is happening. This we have seen earlier also, and just for an example, just for a refresher of earlier thing, the for loop, just I was showing, this is the syntax for loop. This you had seen earlier, right? So this particular syntax have to be followed, otherwise error will be coming. So if you run this particular thing, it will be there. So any other, this is all fine like earlier things only. So now you'll be moving on to the learning part. Okay. So either function approximation or classification you will study. First it will be starting with linear regression, so next week we will be seeing about that. Alright. So till now I think it's fine for everyone. Any doubts in this particular thing or in the questions discussed earlier, you can tell me. Just put in the chat window. if any doubts are there. If you have any doubts, you can just ask or just put in the chat window also. Otherwise, we will stop with the session today. Okay, I hope no one is having any questions. So, okay. So, I'll see you, every one of you, next week. Have a nice rest of the day, everyone. Thank you.